Space exploration, a glimpse beyond our world. Space exploration has captivated humanity for decades, driven by our innate curiosity and the fundamental question of whether we are alone in the universe. Recent advancements in technology have propelled us further than ever before, with missions increasingly focused on identifying potentially habitable environments beyond Earth. One particularly noteworthy endeavor is NASA's Perseverance rover mission to Mars. Launched in 2020, Perseverance landed in Jezero Crater, a region believed to have once been a lake billions of years ago, and has been diligently collecting rock samples for potential return to Earth. This isn't simply about finding evidence of past microbial life. It's about understanding the geological processes that shaped Mars and whether those conditions could have supported life as we know it. The core objective of Perseverance is astrobiology, the study of the origin, evolution, distribution, and future of life in the universe. The rover isn't equipped to definitively prove life existed on Mars. Instead, it searches for biosignatures, indicators that could suggest past biological activity. These include specific mineral formations created by microorganisms or organic molecules preserved within rocks. The process is meticulous. Perseverance uses a suite of sophisticated instruments like SHERLOC, scanning habitable environments with Raman and luminescence for organics and chemicals, to analyze rock compositions, and drills core samples from promising locations. These samples are then sealed in airtight tubes, awaiting a future mission designed to retrieve them for detailed analysis back on Earth using far more advanced laboratory equipment. The search isn't limited to Mars, however. Missions like the James Webb Space Telescope, JWST, are revolutionizing our understanding of exoplanets. Planets orbiting stars other than our Sun. JWST doesn't directly see life, but it analyzes the atmospheres of these distant worlds by observing how starlight filters through them. Different gases absorb light at specific wavelengths. Detecting certain combinations of gases like oxygen and methane could be a strong indication of biological processes occurring on the planet's surface. This technique, called transmission spectroscopy, allows scientists to remotely assess the potential habitability of planets light years away. While finding definitive proof of extraterrestrial life remains elusive, these missions are providing invaluable data about the prevalence of water, considered essential for life as we know it, and the diversity of planetary environments throughout our galaxy. The discovery of liquid water beneath the icy surfaces of moons like Europa, Jupiter, and Enceladus, Saturn, has further expanded the scope of the search, suggesting that habitable conditions might exist even in unexpected locations within our solar system. These subsurface oceans are shielded from harsh radiation and could potentially harbor life independent of sunlight. Ultimately, space exploration isn't just about finding aliens. It's about understanding our place in the cosmos. By studying other planets, we gain a deeper insight into Earth's own history, its unique characteristics, and the factors that allowed life to flourish here. The ongoing missions represent a significant investment in scientific knowledge and technological innovation, pushing the boundaries of what is possible and inspiring future generations to continue exploring the vast unknown. Questions. Write T for true or F for false. 1. Space exploration is solely motivated by the desire to find extraterrestrial life. 2. The Perseverance rover was launched in 2010. 3. Jezero Crater on Mars is believed to have once contained a large ocean. 4. Astrobiology focuses only on the search for current life forms in the universe. 5. Perseverance can definitively prove whether life existed on Mars with its onboard instruments. 6. Biosignatures are indicators that could suggest past biological activity. 7. SHERLOC is a type of telescope used to analyze the atmospheres of exoplanets. 8. The rock samples collected by Perseverance will be analyzed on Mars. 9. Exoplanets are planets orbiting our Sun. 10. Transmission spectroscopy involves analyzing how starlight interacts with a planet's atmosphere. 11. Detecting oxygen and methane in an exoplanet's atmosphere is considered a weak indicator of potential life. 12. JWST directly observes life on exoplanets. 13. The discovery of liquid water on Europa and Enceladus has narrowed the scope of the search for life. 14. Subsurface oceans on moons like Europa are exposed to high levels of radiation. 15. The primary goal of space exploration is to colonize other planets. 16. Studying other planets can provide insights into Earth's history and unique characteristics. 17. The rock samples collected by Perseverance are sealed in airtight containers for future retrieval. 18. The passage suggests that finding extraterrestrial life is a certainty. 19. NASA's missions represent an investment in both scientific knowledge and technological advancement. 20. The James Webb Space Telescope analyzes rock compositions on Mars.